Hello. Uh, for this episode, I'm going to do things a little differently. Let's look at my notes. Um, so last week I was mainly learning Elixir on stream. And just to keep the goal in mind, I'm trying to develop a sort of toolkit or stack to better facilitate application development, mostly in the mobile realm, so Android, iOS, that kind of stuff. But this week, I'm going to take a break from Elixir and try to re-immerse myself in C programming. And the reason for this is I haven't really ever programmed in C in a serious way. You know, mostly just like experiments here and there, some toy apps, maybe a little bit for school, but I think for school I was mostly programming in Java. And then when I got out of school and went to work, I started programming in C sharp. So I never really did a lot of C programming. So I don't really know much about it except for what I've read and seen others do. So anyway, let's get started. I think I'll make a directory called. Well, I'm just going to do a lot of prototyping. This isn't going to be anything that I would put in production, so I'm just going to be doing a lot of experiments in figuring out what I like and taking inspiration from a lot of different sources. So, I guess I should go over a little bit about what I envision this tool set, the C programming tool set, to be used for. So definitely mobile development. So where the targets are iOS and Android, but also for perhaps web development. There's a site called learnbchs.org. Yeah. So the BCHS stack is basically just BSD, C, HTTPD, and SQLite. So basically all tools available on OpenBSD. So I think that looks pretty interesting. So BCHS stack. So these are the primary targets that I'm envisioning for, and when I think of the mobile development, I'm mostly thinking of like simple UIs, lists, buttons, that sort of thing. Nothing too complicated. So not like 2D game development or anything like that. At least not yet, because I really am a rank beginner when it comes to stuff like this. And I'll be mostly spending the next weeks or months learning as I go. So anyway, I guess I'll just start with doing main.c. I'm hoping my Vim environment is good. Let's see. So we can just do a simple example just to see that everything looks good. Int argc car star argv, and then I guess we'll have to do include. Oops, let me exit out of this. Include standard io.h. And then I want to create a Makefile. Just a simple build system. Oh geez. Let me see. Okay, so let's say all and dot phony. Get the compiler. Okay, that works. I think cool. What else? Excuse me. So something that I need to figure out is the style of development. Or rather, not the style of development, but yeah, I guess you could call it the style of development. Do I want to like I need to figure out. Like, I'm pretty sure I'm going to be using the style guide that comes with OpenBSD for their kernel development. I'm not doing any kernel development, but I just think it's a pretty comprehensive guide and something that I'll be using in my own code. However, I do think that I should use what is it? Rust data types, for example. Like, what is the website? Like Rustling learn. Do I go there? Okay. Yeah, read the book. Here we go. Data types. Yeah, so they have various different data types here, signed and unsigned integers that are 8-bit, 16-bit, 64-bit, blah, 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 blah. And they also have floating point types. So F32 and F64. So I'll probably take that. Now, I think the way I do this is well, let me just include stdint.h, and I think I can. Whoops. I can go to the definition of it. int 32t. I don't have a language server up and running on this. Do I want to do that? No, I'll just go into user local user. Is it user include? Maybe. Then where would I find libsy? Here we go. Std int.h. Okay, typedef. Okay, let's see. Machine types. No, okay. So I could probably do like, what is it? Typedef. Something like unsigned car U8 32 64, and this will be a short. This will be a int, and this will be a long. Although I'm not sure why I know that. I'm not sure how I know that. And this will be U32. U32. No, wait. No, these are signed. Oops. What am I doing? Okay. And so let's just... and then... replace this with I. Okay, so this will be I32, I32, and then I8. Oh, right, it needs to be a car. Okay. So if I make that and I run that, same thing. And just to make sure that everything's good here, maybe I could do size of U8. And then do size of does this work? Cool. Size of, and this is in bytes, so 1 byte is 8 bits, so that sounds correct. What is this warning? Format specifies type int, but the argument has type unsigned long. What is the... I'm gonna have to look this up because I don't know. What is the format? Okay. Printf. Long. Maybe it's man 3 printf. Yeah, okay. What is the format for long? Signed. Okay, here we go. LD. All right, and then I think I'll turn on all and everything. Let's move that and do make. Let's see. Unused parameter arg c. Okay, so I'll just change this to void. Cool. And then let's see. Do this for other unsigned integer. 16, 32, 64. Okay. 2 bytes, 4 bytes, 8 bytes. Cool. And then we'll do the same for the signed integers. Cool. And then I guess we gotta do floats. Have to float F32. Now I'm wondering, is this colon necessary? Maybe not. I don't need this. Expected after top level declarator. I guess I do need it. All right, I'll get rid of std int. And then double F64. Cool. And then I'm probably gonna need Boolean. But if I look here, that's std bool. Why is this highlighted? That seems a little weird. It's not executable. Whatever. I don't. Whatever. Okay. Let's say. So I can do. I can do. Let's see. So I definitely want. I guess we'll typedef. Underscore bool as B8. Let me just confirm that that is the case. Yeah, okay, that is 1 byte. And then we'll define true equals 1 and false equals 0. Oops. Okay. So I've got these scalar data types. And I don't know enough about what I need to like even begin thinking about compound data types. So I guess I should return. Warning. Macro is not used. Okay. Cool. Let's see. What else? Let me think. What else would I need in a sort of, I guess, core component of the programming environment? Oh, is this? Oh, this is because that I get it now. This is a symbolic link, so that's why it's a different color. Okay, that's cool. What else would I want? Let me think about this for a couple minutes. I'll be right back. All right, I'm back. So I've given it some thought, and here's where I'm kind of at a sticking point. So opening up my notes, and I know there are several things that I want to be able to, that I'll need to code. Let's just say to do. So we've got our data types. Something. I'm also going to have to do pre-processing of things like pre-processing flags for. I'll need the operating system, the architecture, whether it's AMD 64, ARM 64. I think those are the major architectures I probably want to support. And then things like compiler, but I'm just using Clang. Sorry. So the operating systems I need to be able to detect. I need to be able to detect OpenBSD, iOS, Android, and I guess maybe Mac OS if I'm going to be developing for iOS and Android. I probably need a Mac at some point to do that. And then after that, I need like a memory. I need to be able to manage memory. And then so my aim is to avoid using libsy as much as possible. It's probably not very possible to do that. And then so I'll need a string library of some sort. Buffers. So basically output and stuff. File descriptors. So standard in, standard out, and just basically basic file reading, writing. What else? Probably need some sort of sound. In this case, WAV files, and then graphics. Not sure which graphics I'll be using, but I mean, probably on Android it'll be OpenGL, yes, or embedded. And then for iOS and Mac, either Metal, although I don't really know much about any of this stuff, so I'm just spitballing here. And then OpenBSD. I don't know if I'll do very much graphics programming in OpenBSD, so that's not really something I need to worry about there. There's a lot of stuff to be going off of. So I've done this. I'm not really going to worry about this stuff until I actually do mobile development and need to be able to differentiate between the different architectures. And I guess I need to figure out memory. I'll probably do arena allocator or a linear allocator. I've done quite a bit of reading on it, and it seems to be pretty simple to implement. And the nice thing is that OpenBSD, iOS, and Android, they're all Unixy systems, I want to say. So they have POSIX compliant libraries. So I can use memset, or is it, hold on, mmap. Yeah, mmap. And Actually, I don't. I'd have to log into my Mac to check to make sure that it has mmap. And I obviously I don't know the situation on whether this system call is supported on Mac OS, iOS or Android. So that'll be interesting. So I'm trying not to no dependencies on libsy. So that includes stuff like printf, fopen, null, terminated strings, stuff like that. I mean, obviously, I'm gonna have to look into the operating system. Anyway, so I guess I could try to I guess I could try figuring out okay, just making sure that that's still working. Maybe I should try taking a crack at the arena allocator. Hmm. So if I'm going to be, but I kind of want to, let's try, let's make this into a new file, call it base data.h. And then we'll just plop all this stuff over there. Unknown type name underscore bull. Oh, it is it? Does it not know what to do with this? All right, I'm back. I'm not really sure what happened there, but there was a connection error of some sort. Hopefully it's resolved itself by now. But sorry for the technical difficulties. Anyway. Let me try to gather my thoughts again about what I was going to do. All right, I was going to try out the arena allocator, or at least try to figure out how to do it. There are a lot of examples of this online. My only thing is, how do I test this? Okay. Can I figure out how to print a pointer? Okay. So if I have a assigned integer 32 of I, yeah, okay. Jesus. And then, no, hold on. And then I print f address of I, p, address I, format specified. Okay. So that's specifically for void pointers. Okay, to print strings. I mean, what does this give me? Okay. I mean, good enough. I won't worry about the warning there yet. So the way I understand arena allocators is so let's say arena okay. There. Excuse me. There's a U64 there's like a void pointer to some sort of memory. There's a U64 position, the current position. There is a U64. I think that's basically it. Hmm. What is the style for that? Okay. So like this. What else do I need? Now, let me think about this. So, if I think of this, let me just visualize this memory stuff. All right. And then, let me, okay. So the address of the arena is the same as the address of the first position of memory. Address of arena, because it's the first item, and that's just how it works. So I should be able to, maybe I can do it like, hey, so the way I'm getting a little lost in the weeds here. The way I understand the arenas to work is that you let's see, ask the operating system for a large block of memory. And then let me just get rid of this. And then set the position to 0, I guess. Let's say that. And then when someone asks for some memory from the arena, update the position to the size they ask for, and give them the address to the well, hold on, to the previous position, something like that. So I guess we also need like capacity. Yeah. And then you can make this a little bit more complicated, I guess, by instead of asking for OS for large block, like this would be like use malloc. You can also use mmap to reserve an address space, and then use mprotect to commit that, to commit a certain block or portion. There's a lot of different ways you can go about this. So, this arena, there is going to be the first first 8 bytes is the capacity of memory within the arena. And then the next 8 bytes are the current position. And then, so wait, hold on. This is the arena. And then everything after that is reserved for memory within the arena. Something like that, I guess. So the arena is at least 16 bytes, but will probably be more. Okay, so now that I've kind of understand that, let me think of a basic API or interface. Okay, so I need some method to reserve arena or initialize. And then I need to push memory onto the arena, and then pop memory off of the arena. And then just to make this clear, the current position refers to the current position within the arena. Everything before that position is reserved memory. Or yeah, just reserved. Okay. Okay. Reserve or initialize the arena. Push memory onto the arena. Pop memory off the arena. Okay. Now, this is the API for the arena. There could be differences. Excuse me. There could be differences in between my different targets. So yeah, right here. I'm pretty sure they use mmap in Mac OS at least, but I'm not. I've never worked in iOS or Android, so I have no idea what they use there. So I'm going to need some sort of compatibility layer or OS layer. So to reserve memory and release memory, or at least commit memory. And I guess unreserve. I don't know. Do I even need to release? I'm not really sure if I need to release memory. I mean, yeah, you want to make sure there are no memory leaks, but for the lifetime of the program, I'm just gonna have all the memory that I reserved as one giant block, and I don't want to release it because memory. Asking the operating system for memory is a pretty expensive operation. If I keep doing it over and over and over and over again, there's a chance that the program might fail. And I want to limit failure states. So yeah, I'm just gonna. I guess I'll just worry about reserving and committing memory. Yeah. So what would that look like? Let's just start with this. Void. Maybe a void star, because we're asking for the address to a large block of memory, and we'll just prepend that at memory reserve, and then we'll want size. It's not return a value. Okay. So let's look at mmap. And I guess I could use malloc, but I kind of don't want to. Let's see. So mmap void address size t. Int protect, int flags, int file descriptor offset. So I don't really care about where the memory is, so I'll just pass a null there. So I'll return mmap null. And then we'll pass in the size. And then some of the flags we'll do are, I guess we're just reserving here, so we'll just do protect none. I need assist mman. Okay. So this command .h detect none, and then we'll map this to it's not going to be shared, definitely. It might be anonymous. Map anonymous memory not associated with any specific file. Okay. Do I use anon or anonymous? Okay, well, I'll just do anon. And then there's not going to be a file descriptor. We'll just pass it -1 and offset. If an FD and offset are specified, the resulting address may end up not on a page boundary in order to align the page offset in the address to the page offset in offset. So I'll say 0. So yeah, okay. Let us let's test this out. OS memory reserve. All right, we need a size. Let's just reserve 8. Is 8 fine? Format. Declare static if function is not intended to be used outside of this translation unit. Okay, fine. And then warning. Format specifies type void star, but the argument has type void star star. Oh, okay. So I don't need to specify the address. Cool. Cool. So I've reserved some memory. But I can't really do anything with it until I commit it or call mprotect. So I'm not really sure how this works. So let me just do some more back here to this previous state. And then go back and redo everything. Okay. We'll just cast this as void star. Okay. And let's say value is D. Correct. Okay. And so this is a pointer to some memory. So I could do I32 star pointer PI equals address I. And then I can do PI here. Okay. And then if I want to update the value of this, I could do PI star PI equals yeah. Okay. So I guess this is destructuring or deconstruct. I don't know what the term is. But PI is the oh wait, hold on. Yeah, okay. So PI is the pointer or the address. And then when I do star PI, that's the actual value of I. So same thing here. I can say we have an address in memory. And then we could do something like that. Void, argument type void is incomplete. And we'll just cast that to, I don't know, I64. Operand of type void where arithmetic or pointer type is required. Yeah, I'm really not sure how to do void memory operations. Operand of type void where arithmetic or pointer type is required. What happens if I do this again? Argument type void is incomplete. Memory. Let's change this to size of I64. Okay. We have an address. Say it I64. Excuse me. I64. X equals I64 type void where arithmetic or pointer type is required. Hmm. Maybe I need to do star X. Okay, yeah. Okay, so this is a void pointer, an address in some space. And I assign that address to X. And then I say X equals some random value. Whoops. Some random value. And then I can say X. Oh, do I need to say that this is L? AKA long. Okay. Probably won't work because I haven't actually protected the address. Or specific. Fine, Jesus. Void star. Yeah, segfault. Because I didn't actually I reserved it. I reserved this memory, but I didn't commit the memory. So that is expected. That's what I expected to happen. Okay. All right, so let's write let's say static void OS memory commit. And we'll take a void pointer and a U64 size. Okay, so let me look up mprotect. Okay, so it takes a void pointer, size, and the flag. All right, so mprotect. Okay, the void pointer, so memory, and then the size, and then the flag. I want to be able to read and write this memory. So I'll say protect, read, protect, write. Use, oopsie. Unused. Okay, just chill. And then OS memory commit memory, and then size of I64. And now we didn't segfault. Cool. Let me just change this so that it's more clear. Yeah, cool. So let me see. Let's say that's the value of X. This is the address of X. And then the address of memory. Just to show that they are the same. Yeah, they are the same. And I haven't been I haven't been cleaning up or releasing this memory because, from what I understand, and I could be wrong, once the program is complete, this memory goes back to is released back to the OS anyway. So there's no reason to continue to release this memory in such a granular fashion. So I think I have these functions look fine. So I will put them in their own file. Let's see. I'll just declare these functions, and then I will include OS memory .h, and then need this, but I'm declaring it here too, so I need to do an include guard. If def, if not defined, base data h, and if define base data h. Cool. And then I need an OS memory C. I guess this could go into the implementation file because this header doesn't know anything about sysmman. Yeah, okay. OS memory. Okay. Include. And then I just yoink these. And I yoink this. OS memory.h. Undeclared identifier. Wait, what is this? Can't remember how to bring up the quick fix menu. Open. Oh, it's not in the quick fix. Maybe in the location list. L open. Here we go. Undefined use of declared identifier null. Oh, is null? Oh, so null might be a libsy thing. Okay, so I'm gonna have to declare something here in my data type. if I go to user include, maybe it's in std int. No. Standard IO. Yes. No. Well, kind of, but not really. Okay. Did std bool? Nope. No, it's in. It's called when I do standard IO. Wait, I just checked this. Maybe standard lib. Nope. I have no idea. String. This is fruitless. So let me look this up. Null is a constant equivalent to 0 or so it's equal to like 0 or that. So I guess I'll just define. I don't really like null. I'll use nil 0. It's just a pointer. So since I have that, unused memory function, unused func. Okay, this is kind of annoying. Maybe I'll just do oh right, I need to change everything. OS memory.h. And also OS memory.o. It depends on OS memory h and OS memory dot c. What else? That's not what I meant. I need to do a .o file, generating a target .object. Okay, so C O OS memory.o. Do I even need the output? Okay, let me just do OS memory. Right, I need to link this. I can do C flags. Oh, and I didn't even use need to link this stuff. How do I do that? Linking is separate steps. Do I just call? Okay. As internal language, but is not defined. All right, I'm gonna take a break for like a couple minutes. Still haven't figured this out though. All right, I'm back. Still not sure how to figure this out, but I've got some ideas. So let's say main.o depends on main.c. They state actually let's just main.o, and then we'll do the same thing we're doing here. Okay, and then this depends on main.o, osmemory.o. Same problem. Error found in header. What's wrong with the header? I don't know. Delete that. Okay, error found in header. Warning. OS memory reserve has internal linkage but is not defined. What's that mean? Let's see. Make main.o. Make OS memory.o. Undefined internal language. OS memory commit. Okay. Do I need to include anything? Sort of linking? Undefined symbol. Oops. Linker command failed. Let's see. So let me just do this. Main. Okay. And then okay. I can also try to clean this up. Because let's see. Yep, that is correct. Well, not correct, but like it's giving the correct syntax. And then I think this is that rule context is a GNU make. In a non-suffix rule context is a GNU make idiom. Huh. I guess it's not. That's not possible in OpenBSD make, which is kind of sad. I mean, here it is. Oh, I guess I need to do suffixes. Okay. We'll just copy this. No? Okay. Hmm. Hmm. Okay. Weird. Let's see. Main.o, os memory.o. Yeah, that looks correct. Or at least that looks like this. Oh. Yeah, it's not. Okay. Okay. I get it. Fine. Jesus. I'll just do this. Okay. Okay, undefined symbol. Look at the main.c. It's calling os memory.h. Undefined symbol. A.ob.o. Okay. So this looks like B flags. I'll put that. Mm-hmm. Yeah. Yeah. Actually, this is also base data.h. Oh, maybe I need to do it like this. Okay. So main.o is base data.h. And then let's actually get rid of these .o files first. We did make them. And then we want this. But this is actually main.o, and this is osmemory.o. That depends on base data.h and osmemory.h. Then get rid of these again. Okay, so back to where I started. I'm gonna make it clean. Target. Move.o and main. Okay. Force. Okay. Let's see. Ooh. Okay. Main.o, osmemory.o. Let me look at this again. LD, undefined symbol, OS memory reserve, undefined linker command failed. Maybe can I do this? Oh, I know why. Okay. Yeah, it's because of this. Actually, I'm pretty sure. Because they're not in the same within the same translation unit. Yeah. I don't want this anymore. Yeah, okay, I'm back to where I started. That was weird. So I think I understand. Yeah, I understand why. So I'm compiling things into separate objects, or this .o and this main.o, but they're separate translation units. And when I had them as static, yeah, it was that they weren't part of the same translation unit, so it couldn't see main.o could not see whatever was in os memory.h. I should have realized that, but honestly, I don't really understand static that much because I haven't used it. I haven't used C programming in my daily job, so I'm still learning a lot. Anyway, do I want to continue on with the arena stuff? Let me see. It's been 2 hours. Maybe I'll call it here and work on the arena stuff later. Probably next week, or maybe yeah, probably next week. But you know, I mean, I haven't done a whole lot. I've just got a couple files. Let me just a couple files. But you know, it's fine. And again, this is just a prototype, so I'm not really gonna keep these as they are. Like, I don't really know if this is gonna be named base data or OS memory. Like, who knows? Let's see. Yeah. But I'm pretty happy with my progress so far. Yeah. I'm pretty happy. So we'll call it here, guys. And I'll probably be back next week plugging away on this or working on something else. I have no idea. Honestly, I like to have a lot of different things juggling at the same time because I can't really hold my attention on any one thing. So last week I was working on Elixir. This week I'm working on C. Who knows what I'll be working on next week? Probably this, but yeah. Anyway, yeah, I guess I'll say goodbye now. Don't die out there, and I hope you have a great week. Bye.